Have you ever seen a firefly glowing in the dark? Tiny flashes of light, floating silently in the air, appearing, disappearing, almost like something unreal. There are no wires, no electricity, no visible source, just light. But how does a tiny insect create its own light? And not just light, but controlled flashes, perfectly timed, almost like a signal. Because once you understand what's actually happening, you'll realize this is one of the most advanced natural systems on Earth. Think about every light source you know. A bulb heats up to glow. Fire burns to produce light. Even LEDs waste some energy as heat. But fireflies? They produce light with almost zero heat. That shouldn't be possible. So what's happening inside their bodies? Because this isn't just glowing. This is chemistry, turning directly into light. Inside a firefly's abdomen, there are specialized cells called photocytes. These are the light-producing cells. Inside them is a system designed specifically to create light. And at the center of this system is a molecule called luciferin. This is the key ingredient. But by itself, luciferin does nothing. For light to be produced, three things must come together: luciferin, oxygen, and an enzyme called luciferase. Luciferase acts like a catalyst. It speeds up the reaction. Without it, nothing would happen. When luciferin reacts with oxygen, with the help of luciferase, energy is released. But here's what makes it extraordinary. Instead of releasing that energy as heat, it is released as light. This process is called bioluminescence, and it's one of the rare cases in nature where energy conversion is almost perfectly efficient. So fireflies don't shine in the traditional sense. They run a controlled chemical reaction. Most light sources waste energy as heat. That's why bulbs get hot. That's why fire burns. But fireflies are different. Almost all of the energy from their reaction becomes light. Very little is lost as heat. This is sometimes called cold light, and it is far more efficient than anything humans have created. Fireflies don't glow continuously. They flash. That means they must be able to turn the reaction on and off. They do this by controlling oxygen. When oxygen flows into the photocytes, the reaction starts. When oxygen is restricted, the reaction stops. This creates those precise flashes. On, off, on, off. These flashes are not random. Each species of firefly has its own unique pattern. Some blink slowly. Some flash rapidly. Some produce long glows followed by pauses. These patterns act like signals. They allow fireflies to recognize others of their own kind. The primary purpose of this light is communication. Fireflies use it to find mates. A male will flash a specific pattern while flying. A female, usually on the ground, responds with her own pattern. This creates a kind of conversation using light, a signal and reply. In some species, something even more fascinating happens. Large groups of fireflies begin to synchronize their flashes. Entire trees can light up in unison. Thousands of tiny lights, blinking together, perfectly timed. Scientists still study how this coordination happens. Their light is not just for communication. It also serves as a warning. Fireflies contain chemicals that make them taste unpleasant. Their glow tells predators, "Do not eat me." It's a signal of danger. Even young fireflies in their larval stage can produce light. They glow from the ground. This helps protect them before they are fully grown. So that tiny light you see in the dark is not just something beautiful. It is a chemical reaction, a communication system, a defense mechanism, and a highly efficient energy process, all happening at once. So next time you see a firefly glowing in the night, just remember, you are not just looking at light. You are watching chemistry, working in real time.